I will record this and I'll upload it to YouTube later today so that you can see, so that you can kind of, if you get stuck, reference this video. So first of all, good job, everyone. And just looking through, these are all of the newest iterations. And if they're not, if I'm going to go through your element and it's not the newest iteration, just let me know and I'll update it. But I think I've gathered all of the newest versions of your models. And all of these are now set to be meshes, just so that it's fast. We need it to be fast. It's already going to be a pretty heavy form. Let me make this a little bit nicer to look at. Oh yeah, and the element type 1, and I can't spell library correctly. Library. There we go. So element type 1, here I've just added a bunch of sublayers, and each of your elements are in one of these element type 1s are in one of these sublayers, right? I will be updating the script so that it every time when it needs to use element type 1, it will randomly choose from one of these, from one of these elements. Right now, as I was testing it out, I was just testing it out with this one, just because it was in layer 1. But all of the elements are here. At least I think all of them are here. We'll see. Okay, element type 2 got an update, and it's basically right now all of the screws will fit perfectly. It's a clean geometry. We even trimmed off some parts of it so that it's easier to align the screw and push it in. So element type 2 is closed double precision polygon mesh. If it's double precision, that's fine. Don't worry about that part. You just need it to be valid and closed. So we have that going. Element type 3 got a little bit of reinforcement, which is really great to see, and also the connections were thickened, and of course the thickness of it also got thickened. So that's great as well. Seems to be a clean mesh and working properly. Good job. Element type 4, nice. We did have a lot of problems with the plates breaking off. Now they will be, they will be solid. That's good. Oh, by the way, I don't see the text. If you're writing something, I don't see it right now. So just if anyone notices that someone wrote in the chat just with a microphone, just let me know and I'll look at the group chat. And there is one thing that I wanted to show how I treated all of these elements. So some of you sent me a polysurface, some of you sent me a mesh, and some of you sent me both polysurface and a mesh variations of your element, and that's great. One last step that I did with these geometries, and I've done it for all of these except for this one, just to show it as a quick tutorial, is I reduced the amount of polygons that the geometry has, because here you can see, like on the top of the plate, there are many polygons that are unnecessary, right? That are just there, but you might just have, a large polygon here instead of 6. So what Rhino has is, if I just select the shape and I type in reduce mesh, that's reduce mesh. If I type that one, and instead of saying to how it should reduce it, instead of saying how many polygons it should keep, polygons are again those kind of rectangles, the subdivided surfaces. Instead of using that, I can see planar only. So what it's going to do, and let me just select planar only and hit OK, and wait for it to do the reduction. It's kind of good. So what it's doing right now, it's measuring what kind of polygons are in the same plane, right? What kind of polygons are flat compared to each other, and it's trying to merge them into one, bigger polygon. So by the end of reduction, it will look like this, right? It still, of course, has subdivisions because it always needs to connect the corners. But now it's much less. Actually, here above the command line, you can see that instead of 233,000 faces, we have 46,000, right? So it's 80% reduction, or we're only left with 20 faces, and it doesn't sacrifice quality whatsoever. So the quality of the shape is absolutely the same as it was before, only now it's much, much lighter, which really will help us. So that got all reinforced, that's great. Then this funky thing, it's actually pretty nice. It seems like there's going to be a problem with adding a screw in, but actually there was some Boolean operations happening here, which will let us align the screw a little bit better, and fit it in the holes a little bit better. So this shape will actually work. It's strange, but I really like it. Then here we have a thickened version. So Thor did, this is Thor's, right? I think it's Thor's. So Thor did a bunch of walls and slabs for his first iteration, and now he went to a much more tectonic, not tectonic, technical, or technique look, like a designed object. And I think that's absolutely fine. Like looking at how you would push in the screws, I think they will fit. I think they will fit. We'll see. What? We've removed, yeah, cool, love it. Anyway, so all of that seems fine. Oh yeah, and this kind of thing happens if this kind of subdivision of the surface happens, and it cannot be reduced with planar checking. If your surface is slightly bending, right, it's still going to keep that. But this is fine. It's, I believe, yeah, it's a closed mesh, right? So it's fine. That's good. Lara, nice. And I have double checked the shape, and it's a closed mesh. Everything is fine. Everything works. Nice reinforcements. That's good. Here, it's actually pretty sweet. The only problem that we're going to encounter here is adding the screws, right? Because the disc that is around here, let me actually just try and model out a screw. Not like that, like that. Extrude 3 centimeters. So that's how long the screw is, right? So you can only push it in as far as here, and then it's going to start bumping into the disc, which can be solved in two ways. The first one is Boolean difference. You just carve out this portion for every screw, which I think is fine. For instance, in here as well. So you would need to carve out for every one of these. Or option B is to sacrifice, or not sacrifice, but actually in the joints just trust that on the other side of this element, right? So if we're looking at this element here, on the left-hand side, the element that is going to be added here will be able to, how do I show this? From here to here, something like that. So an element on the other side will be able to incorporate the screw better, right? So you'll end up with a little bit of breathing room here, and then you can just fit in the nut and kind of work around it that way. But I would probably reconsider carving out a little bit of a cut in this disc, just to make it easier to access, basically, for assembly. Other than that, aesthetically speaking, really cool stuff. And you'll see in the renders, you'll see that this element looks really nice. Oh yeah. Nicholas, have you test printed this out? Don't forget to unmute.
No, I haven't test printed it yet, but I sent you the G code.
Okay. So I will, I don't know when, maybe on weekend. Yeah, probably on the weekend. I will test print this. We will just see if this part is too thin. But other than that, you have thickened the connections, so now they shouldn't snap as easily. The connection between the plate and the form itself. So I think it's going to be fine. I'm still not perfectly sure about this whole part, but yeah, we need to test print this and then just see, you know, how it behaves. Aesthetically speaking, really cool stuff. You know, it's really nice. You even incorporated the hole there. Nice. Okay. So, oh, by the way, Nicholas, maybe you're. Do you live somewhere near the school?
5 minutes from school.
So maybe you could start the print yourself then.
I can come in anytime. Okay.
So when you have the chance, just run the print, test it out. I would suggest printing this on a 0.4 millimeter nozzle though, just so that you have better chance of catching all of that detail in the ribbons, and it has, you know, more layers for the ribbon. Yeah. So once you have the chance, just test print it out. There is a SD card to USB converter, or whatever you call it, adapter, in the 3D print lab, meaning that now you're able to just get the SD card from the 3D printer, put it in the adapter, again, which is in the 3D print lab, and use any school's computer to upload G code into the SD card and print from there. So it should be pretty good. So no more need for my laptop. Is someone typing? I'm trying to, yes, chat. Oh, couldn't find it. There we go. Yes, that's very good. Everyone is helping each other out. So it is somewhere in the 3D print lab. You just need to investigate. This element right here, I think it's the only one that I haven't received an update on. Honestly, the only thing, like everything matches here quite. Okay, that's it. Everything matches up here quite well, so the screws are kind of fitting, I believe. maybe except here. So you might end up needing to do some Boolean difference shenanigans to be able to put a screw in there. Let's just see. 3 points here, here, and here. Extrude 2 centimeters. Up, and it goes down. So for sure, you won't be able to, screw it in with this geometry, right? Unless you're doing it from the other side, but then you kind of start bumping into the element like so. I will have just a few, like 50 tops. I think around 50 screws that are going to be 12 millimeters in length. So if I scale 1B, and we will be using the 12 millimeter screws for the most problematic areas. But it's better to kind of fix it, fix it before we need to solve the problematic areas. So this element right here, the only thing that I would, okay, 2 things that I would do. First one is increasing the thickness of this shape, which unfortunately means that you would need to kind of remodel these 2 plates, these 2 triangles. So increasing the thickness of the shape just to make it a bit stronger. And second is using Boolean operations to kind of carve out openings so that you can fit in the screw and actually screw it in. Other than that, this is absolutely fine. Where are we? Here. Yeah, this one is really cool. Considering the joints and so on, like this got the thickness, not the thickness, the radius of the opening got increased quite a bit. So it's actually, you will be able to access the screw hole with a screwdriver, which is really nice. And I believe it's the same thing for every other opening. Like this gap is good enough, and this gap is on the edge of being good enough. I don't think you need to remodel this. As long as at least one joint is fine, it means it can hold the geometry. That is good as well. And again, aesthetically speaking, those veins look really nice. I assume Boolean union operations took quite a while for this element, but it paid off. Looks really nice. Here we have a little bit of simplification from the previous version, and that's great. So now hopefully you'll be able to remove the supports quite well. And also the print time should be better. The only thing now to kind of check is, are these parts too thin? Right, so these kind of bracing parts, are they too thin or not? So from here to crap, I can't. Okay, 0.4, so 4 millimeters in there. I'm just trying to find at least one perpendicular. Okay, let's do it like this. I'll just draw a line from here to here, and a line from here to here. Hide this element. Distance from here to here, you have 2.5 millimeters. And considering that it's chamfered, I assume that the thickness is going to be 3 millimeters in total. So it should be good enough for like strength-wise, but definitely print it out if you haven't already. Test it out, and we'll see. Other than that, all of the screws seem to be, yeah, all of the screws will fit, and that's good to see. Okay, Henrik. So here everything is cleaned up. There were some problems with a bunch of geometries intersecting at a single place, which meant that you wouldn't be able to properly use Boolean union. It would constantly make these kind of non-manifold edges, because if you have a lot of different geometries overlaying at the same edge, let's say a cube, and then I do just isolate it real quickly. So let's say I have a cube and I copy it. Jeez, that's loud. Just do that. No, wait, I can't do that because then I won't hear you. Crap. Okay. I just copy the cube like that, and then copy again and again, something like that. So using Boolean union on something like this, to merge all of these. I mean, these are four boxes, so Boolean union should work. Yeah, it just works. But if you have more fancy geometry and all of them are meeting on this edge, Rhino will start making mistakes, right? So the way I fixed it for Henry was I just made everything intersect more, meaning that in the example of these cubes, if you just start doing this, like forcing everything to intersect like that, rather than just barely touching edge to edge, this makes Boolean union work much better. So in case of Henrik, especially in this corner right here, I just increased the size of these bracing elements here and here, and then Boolean union just worked out. So that's good. From the perspective of adding in screws and connecting, this is actually fine because these plates, these circular plates, they are not connected to the they're not connected to the geometry, meaning that once it's printed out and you remove the supports, they'll just be loose, kind of squiggling around. Which means that if you need to put in a screw through here and this circular plate which is nearest is in the way, you can just kind of push it away a little bit, and then you can put in the screw. So this element works as well. I would definitely suggest printing it out, and before we will be doing the main model, right? So printing it out and just making double sure that all of the connections are viable, so that all of the connections kind of work, and you can indeed put in the screw in every one of the connections. Oh, by the way, important note is that we do have 700 bolts or 700 screws and 700 nuts in the 3D print lab. It's right in the back of the 3D print lab on top of the metal shelf, right? So if you want to test out whether or not the elements, whether or not the screws fit in, or if you want to join up your elements, just take some nice pictures, then you can just use those screws. We will be later on disassembling all of your elements or all of your assemblies, removing the screws and reassembling everything into one big model. And for that, I will actually need to count how many elements we have already printed out, just to see how many we still need. And now the last element here, great job in like I really enjoy this because cuts like these, like Boolean difference cuts like these, they really compromise the strength of this plate, right? And if we didn't have these kind of pipes that were going around and on both sides of the element, if you didn't have these pipes, then these two cuts, which are basically parallel to each other, and also on the opposite side, make it so that this element can snap in half really easily, right? But since you've made these arcs or these circles, cylinders, whatever, since you made these, they reinforce the whole shape, and suddenly it cannot snap anymore because it's like a bracing system, right? So it's reinforced. That's very smart. A very smart thing to do, and I believe this is the only form. Yes, the only form which is just a surface that is kind of a minimal surface that is bending, which kind of introduces variety to the library that we have. Right. So I just quickly went through the updates and the changes to our elements, depending on what kind of elements we had for the measure view, and we're so close to having a final library and finally starting to produce the final model, which is great. Every element, so this is for all of you. Every element will need to be painted. Every element that we print will need to be painted. That's the tedious part, but also quite fun because you can choose how, let's say this one, because it's the first one that I saw. So you can choose which parts of your element are going to be done in what kind of color. We will have, right now I'm trying to buy the thing, but it's through Lund University, but it's a pretty hard thing to do considering that the whole administration is completely swept with the Corona situation. So all of the payments are not going through and so on. It's a bit of a hassle. We'll need to wait a little bit for the paint to arrive, but basically we will have black color, which is going to be for most of your elements, not elements, but for most of the surfaces of your elements, we will be using just black. I'll try to get matte black, this kind of a charcoal, to get this kind of charcoal effect, to make it so that it doesn't look plasticky anymore. But it's going to be, so the base color for every element is going to be black. And then we will have two more colors, which are going to be red and gold. It's just, we're all about that fancy lifestyle with gold. So we will have red and gold. And the cool part is that you can choose, which parts of your element do you want to be black, which parts do you want to be red, and which parts do you want to be gold. And the way I would suggest you do this is, I assume all of you have your polysurface version of the elements, not the mesh version, but the polysurface. And let me just really quickly do some sort of a example here. So you have some sort of a shape, and I've just done some weird thing. Not a weird thing, but a very simplistic thing. And the way I would design which parts are black, which parts are golden, and which parts are, red, is I would go into V-Ray and I would create three materials in V-Ray. The generic, material, generic, material, generic. So three of them. Black, red, gold. And then I would go into, I would go into the settings of the materials, and for the color, I would just, for the gold, I would use something simple, just a color. You don't need it to be, gold at this stage. Later on, you can just substitute that material with a golden one. But at this stage, just, something like this for gold, something like this for red, and something like this for black. Okay. So we have black, gold, and red, three materials, right? And then I can simply take my form. So in your case, you have a much more complex polysurface. But I would just say, okay, so my whole form is going to be black, right? So I just apply my material to the black material to the whole shape. Okay, so if I were to render this out, I will not be rendering it out right now, but if I were to, this whole form would be rendering out as a black material, right? Oh, by the way, don't use perfect black color, like completely black. Use something like very dark gray. If it's completely black, it will eat up all of the light and it will not render out in a nice way. So it's much better for the color to not use a completely black color, but rather really, really dark gray. Trust me, it really makes a difference. Anyway, moving on. We have this whole shape, which is completely black. And then I can say extract surface. And I can say, well, I want the inside of my thing here. I want the inside to be gold, right? So I extract all of the surfaces which are on the inside. Let me just move them up so that you can see. So all of these got extracted, the interior surfaces. And I can actually use join to join them up into one polysurface, right? So we have, or group would work as well. So we have two geometries now. And I'll just apply gold or red material to my interior surface. Apply to selection. So now the outside is black, the inside is gold. And then I can do the same thing, extract surface, that, and that, like so. And use red material on the ends, for instance, of this box. And now this is a really good thing because now we can test it out. Now we will be testing out if me starting a render will actually break zoom and my camera will stop working or something like that. We'll see. So let's test it out. Let me just make this smaller and turn on interactive. And I will be talking throughout the rendering process, the interactive rendering process, just for, I don't know, 15 seconds, 20 seconds. And once I stop it, then you'll just let me know if, the screen got really laggy, or if my voice started cutting off, or if my webcam stopped working or something like that. Because usually when I run the render, it starts messing up the recording, and it starts messing up the actual web conference quite a bit. So let's see what's gonna happen. So I'm starting the render. What the? Oh yeah, we kind of need a light source. So let me just introduce a light source here. Like that. Why the heck is this whole thing not black? I'll just make it black. There we go. So now I have over here. No, so now I have three different materials, and let me stop the render. Stop the render. So how bad was it when I was rendering out with interactive? Let me know. I'll just wait. Huh. Okay, so it wasn't nice. Super. Oh, that's so good to hear. So I will be able to show you one tutorial that I really wanted to show you. That's good. Anyway, so hopefully this makes sense. You know, taking the polysurface element and separating it into pieces, attaching three different materials to three different pieces, and just choosing which parts do you want to be in which color. So again, we will be using, for spray painting, we will be using black, gold, and red. And the way we're going to do it is, first we're going to spray everything black. Then we're going to take duct tape or painter's tape and kind of tape out or mask out the parts which we don't want to paint in red. We spray paint, portions of the element in red, and then we kind of repeat it for the gold color as well. So that's going to be a little bit tedious, but aesthetically speaking, it's going to look really, really good for your portfolios and also for the final model, which is, I guess, the same thing. So now, two more things. First one, and then we'll stop this session. So I'll show you one more thing, then we'll have a quick break, and then I'll continue on with I'll continue on with the tutorials of rendering. Chat. And well, the screws are black, so we won't paint the screws. The screws are fine. You can paint the screws gold if you want to, but fancy screws. But no, we will be painting the elements disassembled. If you want to paint the screw, you will need to only paint. You should only paint the cap of the screw, because if you paint the threaded part, you'll have a rough time trying to fit in a nut on it and so on. But yeah, those of you who want to paint the screws, you can. It's just keep in mind that the screws themselves are black. I ordered them to be black, just for the purpose of aesthetics. Anyway, here I have a slightly updated version of the definition that we've done during the tutorials. And on your own computers, when you're going to, and I will be, of course, sending out the definition together with the central file. So you can see the name of it, central file here. So, so when you're going to open up this definition for the first time on your laptop, it might start asking you to install the Cocoon plugin and also to install anemone plugin, right? So that's the anemone is for the loop, and the cocoon is for the marching cubes mesh for this thing. So for this definition to work, you don't really need to install the cocoon plugin. Actually, let me just do this. There we go, fixed it. So don't worry about the cocoon plugin, but you will need to install anemone plugin on your computer, and it can be just downloaded from Food for Rhino, just like we've done it in the during the tutorials in the school. Things that have changed here. I'll show this in a bit. The things that have changed here is this group right here, which is basically a mesh join, and also it's a cluster. So if I double click the cluster, there's a little bit of things going on here with text editing. Don't worry about that. But the basics of what the cluster gives us is, oh, come on, type 4 doesn't exist. I'll fix that before I send it out. But wait, that's type 4. And I can literally see it here. Oh, yeah. During the tutorials, I've rebuilt this this mesh, so it cannot recognize the mesh anymore. So I need to do set one geometry again, and now it's going to work. Okay, sorry for that small hiccup. Anyway, moving on. Now it should. Oh, and I need to restart the loop. Before I do that, the points that I had here were just copied points from this library, meaning that in doing so, I make sure that all of your elements are used for this test. This is not a final model, by no means, but this is just me making sure that everything fits and everything works properly and all of the elements are connecting properly. And they seem to do so. Let me run the definition again. And while it's doing that, oh, by the way, if it's going to start lagging, let me know, because this is, again, this is going to be as intensive for the computer as it is to render something out. So it might start lagging, but if it's not, it's not. So back to this cluster right here. So the tutorial for it is on YouTube, on how I've created it. And the basic principle of it is it's using this lagging now. It's taking the library of your elements, so of all of your 14 or 13 meshes here, 14 meshes, and it's cross-referencing the meshes that you have in your model here, right? Hopefully you can see my mouse. So it's taking every mesh, every element from your not assembled, from your big model, and it's checking, does that mesh have the same amount of points as any one of these meshes in the library that I've set out, right? And then it's just counting, it's just adding numbers. It's not updating live here because I have a data dam, which is here. If I press the play button now, it's going to update. And now, okay, so now it works. Now we can see that we are using 66 elements of type 1 for this particular structure, 30 elements of type 2, 16 elements of type 3, and so on, right? And the further you go down the list, the less elements you use. That's honestly how it works. I will try to slightly balance it out with the for the final shape, so that at least 2 or 3 elements are used of, every no, at least 2 or 3 elements are used of every type. But for this particular experiment, this is how many we have, right? So that's it's going to inform us how many we need to print. So that's this cluster. Again, a tutorial for it is on YouTube, and it's called Element Statistics, so you can check it out there. Let me dig this out. I don't need to group. So if I want to bake this shape out, I bake it out through mesh join. So this guy just joins up all of the elements into a single mesh, meaning that I will not be able to select every element by itself, but at the same time, it's going to be easier to kind of rotate and work with the geometry as one single mesh, and it's going to be lighter as well. So I'll just bake it out. It's gonna take a while. It's not a light mesh here. You guys really did let's see, quite complex geometries, which is nice. But now we will need to pay the price, of them being complex. And let me take this and actually rotate it 90 degrees. It's not, even rotating takes a bit of time. Okay. And then let me make it pretty. So we have a shape that looks something like this. And you'll be able to, if you look closely, you'll be able to see, all of your element types that exist there. And this kind of really cool shape emerges from your elements, which I think this is pretty damn cool. We'll again, I will be doing the final point cloud. I'll try to do it throughout today and tomorrow, and I'll be sending it out as a separate email. The final shape, Before this webinar or whatever we call it started, I have tried rendering it out, but I didn't have enough time. So I just managed to render out a very noisy image with some parts, with some parts cleaned off, but other parts are still pretty noisy. But you can see, like from aesthetic standpoint, it's not even something that's just kind of experimental point cloud, which doesn't have any symmetry, it doesn't have any thought about aesthetics. It's just your elements assembled into the whole shape, is already quite pleasing to the eye, and it's quite architectural in that sense. I think it's going to look really nice. I will be rendering out a bigger image here, but why is this popping up? I will be rendering out a bigger image, and I'll just send it out to you guys to take a look, or you can do it yourselves as well. Anyway, so that's where we are at right now. We have a 99.9% done library, which is 99% done, and we have a working definition, working Grasshopper definition, which we'll be able to use for the final for the final shape. Speaking of complexity, for instance, this mesh right here, which contains 168 elements in total, this mesh right here has is that 2 million? Yeah, 2.5 million polygons. Right, so I assume we will end up having a shape with, that was 168, right? 168 elements. So let's say we do 300 elements, so we will have around 5 million polygons, which is going to be pretty tricky to render out. Not tricky, it's just going to take some time, you know, waiting for it to load everything in before it renders out and so on, but I think we will manage. So now, okay, now on to questions. Do you have any questions about this? You know, about what I've